Hello friends, the topic of today's lecture is Bamford-Steven reaction. It is similar to the Shapiro reaction we have discussed in the previous lecture. It is defined as the reaction of tosylhydrazone having alpha hydrogen with base like sodium hydride, potassium hydride, sodium methoxide, sodium ethoxide, etc. in the presence of protic solvent like ethylene glycol or aprotic solvent like diglyme under heating condition to produce alkene. The overall changes in this reaction are removal of tosyl hydrazide group, formation of a pi bond between the carbon bearing R1 and R2, and addition of H at the carbon bearing R1. Mechanism of Bamford-Steven reaction. We know that Bamford-Steven reaction occurs both in protic and aprotic solvents. Let's first discuss mechanism in protic solvent. This is the tosylhydrazone. Suppose the base is methoxide ion. Methoxide ion abstracts NH proton to produce anion, which expels out para-toluene sulfonate to produce this diazoalkane intermediate. This diazoalkane intermediate abstracts proton from the solvent to produce alkyl diazonium species. This alkyl diazonium species liberates nitrogen to produce carbocation. Now, carbocation eliminates proton to produce alkene. Now we will discuss mechanism of Bamford-Steven reaction in aprotic solvent. In aprotic solvent, the steps up to the formation of diazoalkane intermediate are the same as in the case of protic solvent. So we are not going to write those steps here. This is the diazoalkane intermediate. The resonating form of this can be drawn like this. Liberation of nitrogen gas will give carbene intermediate, which undergoes 1,2 hydrogen shift to produce alkene. Regioselectivity of Bamford-Steven reaction. In Bamford-Steven reaction, more stable alkene is predominantly formed. If we talk about regioselectivity in terms of substitution, greater substituted alkenes are more stable. So we can also say that in Bamford-Steven reaction, greater substituted alkene is predominantly formed. For example, when tosylhydrazone of 2-methylcyclohexanone is heated with sodium methoxide in ethylene glycol, it gives a mixture of 1-methylcyclohexene and 3-methylcyclohexene. 1-methylcyclohexene has 3 substitutions on alkene, 1, 2 and 3, while 3-methylcyclohexene has 2 substituents, 1 and 2. So 1-methylcyclohexene is formed as the major, while 3-methylcyclohexene is formed as minor product. Similarly, when this terpene-based tosylhydrazone is heated in the presence of sodium metal in ethylene glycol, tri-substituted alkene is formed as major, while disubstituted alkene is formed as minor product. Monolithium salt of tosylhydrazone of steroid derivative, when heated at 170 degrees centigrade, produces a mixture of alkene A and B, both with 2 substitutions. Alkene A is more stable than B because of conjugation with oxygen. So A is formed as major while B as minor product. Stereoselectivity of Bamford-Steven reaction. In Bamford-Steven reaction, stereoselectivity is not very great. In protic solvents, a mixture of E and Z isomers result, while in aprotic solvent, Z isomer is formed as the major isomer. Now let's discuss few problems based on Bamford-Steven reaction. In this problem, we have to draw the mechanism for the formation of three products A, B and C from tosylhydrazone X. Tosylhydrazone X under protic condition in the presence of base will generate this carbocation, which after deprotonation will give alkene A. The same carbocation intermediate can undergo ring expansion via 1,2 alkyl shift to generate another carbocation with fused bicyclic ring. Now, this new carbocation after deprotonation will give product B. Product B under heating condition can undergo electrocyclic ring opening process to produce product C. Explain the facts for the formation of bicyclobutane from tosylhydrazone of cyclopropane carboxyldehyde in the presence of sodium methoxide in triglyme under heating condition. In this reaction, tosylhydrazone of cyclopropane carboxyldehyde is reacting with base under aprotic condition, since triglyme is an aprotic solvent. Under aprotic condition, it will generate carbene intermediate, as we have discussed earlier, that will undergo CH insertion reaction to produce bicyclobutane. Explain the facts for the formation of cyclopropene derivative from given alpha beta unsaturated tosylhydrazone in the presence of sodium methoxide in diglyme under heating condition. In this reaction, tosylhydrazone is reacting with base under aprotic condition, since diglyme is an aprotic solvent. Under aprotic condition, it will generate carbene intermediate. This carbene intermediate will undergo CC insertion reaction like this to produce cyclopropene derivative. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much.